This talk is going to be mostly about authentication scenarios for the cloud. And I would like to make it interactive. So if you have any questions in between, you can just stop me and ask questions. You don't have to wait till the end. So this talk is about federated login CSRF, which is something that is part of my research from my work at Microsoft. And I'll be giving a brief outline of the scenario and under which conditions this can happen. So a little bit about me. I'm a security engineer at the Windows Services Pentest team. We have an internal pentest team in Microsoft that looks at our own product. And I'm mostly looking at web apps and authentication and authorization, these kinds of things. So here's a brief outline of what I'll be talking about. I'll do a quick recap of some key concepts that we needed for understanding this threat. I'll present a scenario, which we'll use throughout the talk. Some basics about OWASP CSRF, OpenID Connect Login CSRF, and introduce this new concept called Federated Login CSRF. I'll also give a demo of a short scenario and some sample code if you want to try it out yourself, and propose some mitigations for the same. Here's a quick recap of what federated login is all about. So in an enterprise scenario, most of the time you want to achieve single sign-on, where the user does not have to log in to each application that they have to use. So in this scenario, you have some business application which is on the cloud, and you want the user to have single sign-on with their corporate identity to the cloud application. So how you do this is basically establish trust between the business application and some federation provider, and between the federation provider and the corporate identity. Now, when the user needs to log into the business application, they would get a token from the corporate identity and transform that token using the federation provider and send the transform token to the business application. This is just to recap what is federated login. Coming to login CSRF, this was a new kind of CSRF attack that was proposed in 2008. Where it is not the regular CSRF where you're trying to do an action on behalf of the user. Here, the attacker is trying to get an attacker session on the victim's browser. So what can happen in this scenario is that when a victim or a user navigates to a malicious website, if that website is attacker controlled, the attacker can load his own JavaScript in the victim's browser. Now, using this JavaScript, the attacker could then potentially post username and password to a business application and establish an attacker session cookie within the victim's browser. So I just wanted to introduce the concept of federated login and login CSRF, which is probably what the talk is all about. So now, coming to the scenario where this may be a problem, most of the time, a user is not a single identity in all the online contexts. You might have work identities based on Azure or AWS or Salesforce or whatever you use for work. And you have personal identities like Facebook, Twitter, or Microsoft identities, if anyone uses those. So basically, these were separate initially when these things were designed. But more and more, we are seeing a scenario where your corporate identity is connected to your social identity for some social analytics or posting your activities to Twitter or things like that. So there are more and more business applications that try to do this, where you link identities together. And in this scenario, what happens is you have a business application, which is a multi-tenant business application. You have to understand what I mean by multi-tenant application. It means that you have the same service serving customers from different organizations. So you might have like a company called Contoso and another company called Fabricam, and both are served by the same business application. And these identities are federated using their corporate identity. Like a Contoso user would log into their corporate identity, get federated token, and then talk to the business application. And they are also linking an external social network using OAuth. So this is a basic scenario where the federated login CSRF might be a problem. There are already identified and documented CSRF scenarios in OAuth and OpenID Connect. OpenID Connect is the federation protocol that is the standard right now. So we will just walk through what they are, how it might affect this present scenario, and what are the identified mitigations for those. Yeah, in case of OAuth code grant flow, this is a specific protocol used in case of what they call confidential clients, where you have a web service that needs to connect to an external resource. Here, the objective of the business application is to link the user with some external resource like Twitter or Facebook or whatever the social resources. In this case, the data flow is initiated by the user by using the connect to social profile feature or something like that. And this makes a request to the business application. The business application now initiates the OAuth consent flow, where if the user provides consent for the business application to access this external resource, an authorization request is sent to the external resource. So I've represented the external service as two different entities over here. There's the authorization service and the resource service. But in some cases, they might be the same. But as for the protocol, it could be two different entities as well. Irrespective of that, the authorization service would send back an auth code, which would be sent back to the business application from the client side, which is a very important point over here. It does not send this auth code directly from the server to server. It is sent through the client side. And when the business application sees the auth code, it would use its own internal client secret, which is registered with the external service, and exchange the auth code with, to get an access or refresh token. And these tokens would then be linked to the current logged in user session and would later be used for any request to the external service, like maybe to get a profile picture of the particular user. So what can an attacker do in this data flow? What an attacker can do is follow the same steps up to step 6, where the attacker gets his own auth code and prevents any further communication from the browser to the business application. So he gets his own auth code, he keeps it there. He then would create a malicious email or a website or something and lures the victim to click on this particular link. What that would do is, if the user clicks on the link, would post the attacker's auth code to the business application. Now, the business application sees that this is a valid request because we assume here that the user is already logged into the business application using the user's own identity, but he's posting the attacker's auth code. If this happens, the business application would then exchange the auth code using its own internal flow with the external service and get back an access token, which it would link to the current logged in user, which in this case is the victim. So any data that is retrieved from the external service would be the attacker's data, which might affect any business logic that the victim user uses. So he would expect to see his own data, but he's getting some malicious data in this case. So this is a well-known CSRF scenario in OAuth, and it is mentioned specifically in the spec itself. So if you read the spec, there is a mention of a state parameter, which is marked as recommended, which should be used to prevent cross-site request forgery. And they describe what the cross-site request forgery is in section or whatever. So it's basically whatever I just mentioned. So the thing to note here is that it is a recommended parameter and not a required parameter according to the spec. But if you have to prevent CSRF attacks, you have to use this always. As a developer, you should always do this. And if you're assessing any code from any OAuth implementation, you should always check for whether they are doing the state validation correctly. Coming to OpenID Connect flow, the intention of this data flow is to do federated authentication for your business application. So initially, when the user tries to navigate to the business application, the browser goes to that site, makes a request. The business application sees that there is no user session established currently, and it responds with a 401 unauthorized response. It would also probably try to redirect you to the correct authentication server, which might be a different entity altogether. So it redirects you to the authentication server, specifying its client ID and the registered redirect URL with the authentication server. So what I mean by this is, for configuring federated authentication, the business application has to register itself with the authentication server previously and get its own client ID and a redirect URL. The user would then use his credential, like username and password, and log in with the authentication server, which would redirect back to the registered redirect URL with something called as an ID token. The ID token is a representation of the user using claims, which is signed by the authentication server's internal certificate. This token gets sent from the client side to the business application, where the business application would just verify that the ID token is issued by the right identity server and whether the signatures match. And then if everything is valid about the ID token, it would create a session cookie for the user in the browser. So what can an attacker do in this case? It is very similar to the OAuth CSRF attack, where the attacker goes through steps 1 to 6, gets the attacker's own ID token, and prevents any further communication from the client to the server. So now the business application has not completed the flow of authenticating the attacker, but the attacker has a valid ID token which is issued by the authentication server. What can they do with this thing? So it is very similar to the earlier scenario, where you would lure the victim to an attacker's email or just a website, which would embed the attacker's ID token within it. When the user clicks on this link, it would send the attacker's ID token to the business application, where the business application sees that the token is valid, it is signed by the right identity server, and establishes a session for the victim, for the attacker in the victim's browser. So the end result of all of this is attacker's business app session is established on the victim's browser. So what is wrong with that? I mean, it doesn't seem to be a big issue. However, in this scenario where you are trying to link two different identities, if an attacker's session is created on the victim's browser, assuming that the victim is already logged into the external resource like Twitter, Facebook, or whatever, then you have two cookies on the browser. One is the application cookie, which belongs to the attacker, and the social profile cookie, which belongs to the victim. When the connect to social profile feature is initiated, this would initiate the business application to initiate the OAuth consent flow, where the client ID is the business application itself. And here you can see that the business application implements the recommended state parameter and sets that in the consent dialog. This gets sent to the external authorization service. However, here is what the external authorization service sees. It sees that the current user, which is the victim, is asking for consent for the business application to access the external service. If the victim had previously consented to the same business application to access this resource, this would be an automatic consent. So as far as the authorization service is concerned, the client ID, the user, and the consent required is the same. So there's no change in what is being requested. And if this is an automatic consent, then the browser would just automatically redirect with the auth code for the victim identity, send it back to the business application, where now, since it's using the recommended state parameter, the business application would validate the state is correct and then exchange the auth code for an access token, and then link this with the current logged in user. In this case, the current logged in user is the attacker. Once all this flow happens, all that the attacker has to do is log into the business application again, use the connected feature, and get social data from the victim. So this is under the assumption that this business application reads data from the social network using the stored tokens. Again, as with the OAuth spec, the OpenID Connect spec also mentions a state parameter, which is explicitly called out as a protection against CSRF or XSRF to mitigate these issues. But again, because it is a recommended parameter and not a required parameter, I've seen implementations where this is not used correctly. So you should always check for status, the key takeaway. So all of this is existing research and existing identified problems. Coming to the newly proposed threat, we have a federated login CSRF scenario. If you have this hypothetical business application which uses a federated identity provider, it is multi-tenant and allows for multiple federated identities to be configured. Also, the business application, if it has a connection to an external resource with a different identity, these are like some of the preconditions for this kind of threat. So how would an attacker manipulate this kind of business application to achieve like information disclosure or get more details from a victim? So what an attacker can do is to sign up for a new tenant in the business application federate that tenant with the attacker's controlled identity provider. And basically, the business application already has this feature where it links to an external resource. So this is a key concept. I hope everyone understands that. The business application being a multi-tenant application allows users to sign up for new tenants. And each new tenant can have its own identity provider because of the federation support. If this is configured correctly by the attacker, what they can do is a sequence of steps that ends up with information disclosure. So let's go through this sequence flow. It was too complicated to actually show in a data flow model, so I chose the sequence model. So what happens here is the victim clicks on a malicious link or visits a malicious web page or something like that using the victim's own browser. And this initiates a request to an attacker-controlled website. Now, what the attacker-controlled website does is it would navigate to the business application. And at this point of time, since there is no user logged into this business application, the business application would then start the OpenID Connect flow for getting the user to log in. In the OpenID Connect flow, it also implements a recommended state parameter in a cookie and redirects to its trusted federated identity provider. So now the browser navigates to the federated online identity provider, where the online identity provider sees that there is no user logged in. So it would redirect, it would set its own online identity provider's state cookie. You can see that this online federated identity provider also uses the OpenID Connect flow and uses the recommended state parameter. This would then redirect to the attacker's identity provider. Now, the attacker's identity provider has complete control of whatever it has to do. It would automatically log in the attacker without providing a username and password. It would then send the attacker's ID token to online identity provider, which verifies the state, sees that the state is valid because the state cookies are coming correctly. It would then redirect to the business application with the attacker's ID token. The business application verifies the state again, sees everything is correct, and it would set the attacker's session cookie in the victim's browser. So the end result of all of this thing is attacker has established a session for the business application in the victim's browser. And now the risk is the same as the case of an OpenID Connect flow, where if the OAuth consent flow is initiated, then the social profile of the victim gets linked to the attacker's identity. And all that the attacker has to do is log into the business application with his own identity, get access to the victim's resource. I would now like to show a brief demo of how you can do automatic login. So in this demo, if I can figure out how to, Oh, cool. So yeah, so I've installed a, I should go back a bit. Sorry about this. So what I've done is installed Active Directory Federation services in the default configuration. And in the default configuration, it asks the user to sign in. There is no automatic login possible. However, ADFS has this support for adding custom themes for putting your logo or showing a welcome message when you go to the login page. So what you can do is configure the theme by copying the theme. That's what I'm doing here. And the theme contains an onload script, which is shown over there. It's very unclear. But what you can do is change the onload script with whatever other JavaScript that you want. And in this particular JavaScript, what I do is I set I create a function called auto sign-in, where I set a username and a password, which is shown over there, which would be used for automatically signing in the user when they visit the ADFS login page. Now I set this as the new theme, as the active theme. And now if anyone goes to this page, which is the ADFS sign-in page, you get automatically logged in. That's all the demo is about. And if anyone is interested, I have put it up on GitHub if you want to create your own auto sign-in ADFS login server. Just be aware that everyone will get your password, but that's the intention of the attacker, though. So what can you do with ADFS? If you see the documentation of these online services, there is direct documentation specifically about connecting ADFS for federation with Azure or AWS or Salesforce or Facebook or Slack, which are very popular applications for these multi-tenant scenarios. However, this does not mean that Azure is vulnerable or AWS is vulnerable. Only if there is a specific application that then tries to connect to an external identity would there be this login CSRF attack. However, ADFS is universally supported, so there will be lots of other business scenarios as well. So what are the mitigations for this? One mitigation I can think of, which is probably the best one, is to show a second consent dialog within the business application itself, which would say something like, do you want to allow the social profile of this user to be linked with the business application user of this ID? Something like that. And now it's the user who is making a conscious decision of whether to allow or not allow. A second mitigation would be to use a different client ID per tenant in your OAuth flow. However, this is not a complete mitigation since the customer does not know which user is this context running under. A third mitigation is to use the always prompt OAuth consent flow, which is supported by, for example, Google. OAuth supports this concept of always prompt, where even if you had previously consented, you would still get a consent dialog saying that, do you want to allow a business application to access Google, or stuff like that. But this is, again, not a complete mitigation because the consent dialog does not say which logged in user is this consent going against. Coming to the conclusions, whenever you're linking two identities, be very careful. Always review that scenario. Ensure that state validations are implemented correctly. This is to prevent the known CSRF attacks, not the new one. And consider implementing a second consent dialog for this linking scenario, even though it's not a great user experience, but it helps with security.